And kick it over to Dick.
Hi, guys. Again, thank you for returning. Before I get started, though, there's a question of credit certificates towards your NATEF 20-hour requirements. Jeff's going to give you the answers we have to date. Jeff?
Okay, so this all has to do with when Consulab is back at work. So until that time, we won't be sending anything out. Today, and hopefully for all future sessions,
And
we'll
yesterday.
have and yesterday, we have a quiz to send out to you. And the first thing you do on the quiz is fill out your email address. From that, I can take that document, that form, and send it off to our people in Quebec City, and we'll work on getting you certificates when we all get back to work. Now, for previous sessions where we didn't do that, we're going to come up with a form, and we'll put it up in the chat when we get that done for you to request a certificate for those other sessions that you attended. So you can go back through the website, you could go down through the list and say, yeah, I did that one, that one, that one. We feel that fits the spirit of what Mike Coley talked about from ASE the other day when we had him on. And we're tightening that up a little bit with this form I'm going to send you later on in Dick's presentation. And with that, hold your questions until the end, or tomorrow we'll cover all that, and I'll let Dick get going. I know he's got a lot of good stuff here.
Okay, thanks, Jeff. Let me see what I'm doing here. Okay. Hopefully you'll be able to see my screen here in a moment. Are you seeing a gray screen right now?
No, you're showing off.
Yes.
Oh, there we are.
Okay, very good. Yesterday during the chat session, Carl Smith asked a question about, did you know about the 6-pin Nissan relays? And my answer was pretty vague, so I took it to a challenge and overnight found out about the Nissan 6-pin relays. And what I learned is it's not difficult at all. It's very simple. It's not an ISO standard relay, and I guess Nissan is known for that. But basically, here's some pictures that Carl sent to me of that relay. It has 6 pins, and he sent a couple different views of it. So I went to the Nissan service information and found this schematic showing the 6-pin relay. And from what you learned yesterday, and we'll review that briefly in a moment, you see that it is a very simple relay with 2 sets of contacts and a coil. So that relay would then turn on or off two circuits. So I did a little more research, and my question is, why didn't they use number 4? I don't know why. Maybe they don't have something against number 4, but so we study the relay schematic, which you have to do before you do any testing of the circuit or the relay. And you see that numbers 1 and 2 are the coil circuit. We don't know if it's resistor suppressed or diode suppressed, but if you look on the upper right-hand corner, you see what looks like a resistor symbol, and I'm assuming it is resistor suppressed because there isn't a diode there. 3 and 5 are one set of contacts, and 6 and 7 are the other set of contacts. So it's a pretty simple relay. That information was taken from Identifix in this case, and you would energize the coil there. You see how the coil 1 and 2 are different configuration terminal-wise than the contacts are. The 3 asterisks there, and when I would ask the class the question, why did I say energized coil here but with 3 asterisks? And the asterisks require, well, what if it has a diode as a suppression in the coil? And you want to make sure that you would energize properly, which you will learn how to do today. And here is the schematic of the circuit using that relay. In this case, it's an ignition relay. And with credit to George Menchu and others, I usually use color coding on wiring diagrams to help students understand what this is. So the relay is right there where the red arrow is. And let's diagnose this, or let's learn this circuit quickly. we see that the ignition switch will supply B plus to the coil when the ignition switch is in start or on. And then therefore the other side must be coil ground circuit. Now we don't know what kind of switch is in there. It could be a transmission or it could be anything, but we'd have to go to the next wiring diagram, which I'm not going to take the time to do. But we know now that the coil is positive and negative. And here is one feed coming from the battery through a fuse to one set of contacts, comes out of there and goes to the control device. What is it? I don't know until I go to the next page drawing. I don't care right now. The other set of contacts could be fed by this wire. That's why I said, is this B plus question mark or not? And the other side goes through a fuse, 10 amp. Now you'd say, well, that's got to be the feed. Not necessarily. Many cars use double fuse circuits on the coil contacts, fuse both sides of it. So until I go to a more additional diagrams, I would not know for sure. But at least I know what the 6 wires going to the relay are. So I wanted to thank Carl for asking that question, and I hope that explains basically what we learned there. Very quick review of yesterday, what we talked about. A 4-pin common relay is a make and break relay. We have 30 and 87 and 85 and 86. Then we make a 5-pin relay, which adds 87A, which are the normally closed set of contacts when the relay is off. And then we have that weird one that German cars, Mercedes and BMW use, that turns 2 circuits on with one feed, 87B and 87. Don't be confused by that. Bosch makes that relay quite common, but it's not common in US. And then we have the one with the fuse on it that's found in the aftermarket. I've seen quite a few of these on vehicles and RVs and boats that have added on circuits. That's what it looks like. You can buy these online very easily, quite common. And the 2 ways of suppressing the inductive kick on the diode are the relay coil is the diode and the resistor. So quick review of what we did yesterday. Now, let me move on to today's information. If you have any questions, please use the chat until such time as we open it up for today. We're going to talk about relay testing and diagnosis. We're going to cover static and dynamic testing of a relay, not the circuit. We're going to have the relay out of the circuit and we're going to test it statically and dynamically. And that dynamic part is what I feel that many technicians and instructors and students aren't doing. Dynamic testing in the circuit. So now we're going to test the circuit itself and then testing the circuit at the socket with the relay removed. And this is a very uncommon thing for technicians to do, and they should do because it's so time saving. We'll explain that. And then using specialized equipment. Some of you mentioned some of that equipment yesterday. The full-blown PowerPoint that I will send you with 144 slides has about 6 or 7 different slides of all of the equipment available, including the U-Activate tool from AES Wave, the Lyle, the Kelvan, the Snap-on, all of those plug-and-play adapters. Before you do any diagnosis and testing of a relay or a relay circuit, you know the importance of vehicle-specific service information. You cannot emphasize that too much. In the old days, you could say, they're all that way and probably would be accurate. Today, that is not true, and you must use vehicle-specific service information. I want to introduce something new to you that many of you may not know about. A few of you do. GM was having high failure rates with their fuel pumps, some of their blower motors, some of the more higher amperage devices. And a few years ago, they came out with something they called a high power relay. Now it looks exactly the same as a 5-pin micro 280 relay, but it is able to handle up to 35 amps of current through the contacts. And you want to be aware that these are available if you have a burn contact situation, or, be aware that they have a heavy duty or high power relay. Now there's two types, an old and a new version. And we've come across this, we thought maybe there was just the one type, but there aren't. There are two types. On the new version, the coil resistance is much higher than most all others. It handles higher currents with lower current control by the PCM or BCM. So now we're able to control lots of current with a very low amperage control circuit. Now we know at the bottom, we know that the typical relay has between, some books say 60 to 100 ohms, and 80 ohms is a good ballpark figure for an average older style or conventional traditional relay. The new GM high power relay of the newer version can have 210 ohms of resistance. Now, if you don't know this and you measured a relay coil on your bench and it measured 210 ohms, you'd be throwing away about a $25 relay. They're much more expensive than the standard ones. However, if you have the older style high-powered relay, which is actually shown on the left-hand picture there that has the words high power on the top, that coil will be 80 ohms. However, the contacts have been robustly increased to handle 35 amps with the same coil current. Then they said, well, wait a minute, let's reduce the load on the quad drivers in the computer, so let's make the coil higher resistance, which lowers the current. Notice it took 100 milliamps off the current draw. The problem is, if you don't know this and you put a conventional relay that draws 160 amps in a circuit that is supposed to draw 60, there is the potential of damaging the computer, or you will at least get an overcurrent code. Many computers today are fairly well protected from current and shorts. They have shunting resistors in there and you'll get an overcurrent code. But just be aware that these GM high-powered relays, they're not new. They've been around for a few years, but just be aware that they are out there. Two types, one with 80 ohms resistance, 35 amp contacts, one with 210 ohms of coil resistance, 60 milliamp current draw. And here I took my ohm meter and I have both types, the older and the new style. And you notice that the one on the left draws 82.9 ohms on the coil resistance. And the other one, which is the 135.02751, draws 219 ohms. That is a totally normal, good reading. Just be sure you're aware of that. Bench testing a relay. Relay is out of the circuit. You got it on the bench. I want you to use a test light or a 194 bulb, and that test light should draw about 250 milliamps. And just to remind you, to test the draw of your test light, hook it up in series with your ammeter, your DVM ammeter, and record how much the light bulb draws. Here we have 85 to 86 on the older style. Is 70 to 100 ohms. The two asterisks mean unless it's a high power GM relay at 220 ohms. The voltage drop across the coil is 12 volts. 30 to 87 is infinity when it's off. On is 0 ohms, and we want no more than 0.2 of a volt voltage drop. Just the opposite on 30 to 87A. Does the relay that you have in your hand have a diode or resistor inside? How do you know? It's very simple. You take a test light and you connect it to the battery and touch it to 85 and 86. That relay is going to do one of two things. It's either going to click or not click, but the test light will come on dim. If it does that, you have a diode in that relay, and it's good. If it clicks in both directions, you don't have a diode in there, it's a resistor, or you have a diode, but it's blown. So all you've done is reverse the polarity of your test light, connecting it to 85 and 86 in reverse polarity. If it's a diode, it will click in one direction It won't click in the other, and the light will come on dim because you put the test light and the coil in series with each other, and the diode is blocking the current flow. So your test light will come on dim. The other way, it allows current to pass through, and the test light will energize the relay coil. I never energize a relay coil without a test light. I just don't do that anymore. And if you don't have you don't question a test light, just get a 194 bulb. I'm sure you got all those laying around in your shop. They make a great relay testing tool. To energize a relay on a bench, as a review, check to see if it has a diode. And you're simply connecting it to positive to 86, then you're going to reverse it. Again, if it clicks both ways, the relay has a resistor and the coil is good, or the diode is open, the relay will still function. But if you blew the diode because you use jumper wires, you're going to put a non-suppressed diode back in the sensitive electronic circuit. And you saw yesterday that you'll generate 280 or 300 volts on a spike. That's not a good thing. Do not use a computer-safe test light to test diodes or relays. They don't draw enough current to energize the relay. And I bought the latest, greatest Mac computer-safe test light way back when. I hardly use it. It was a waste of 150 bucks because all it does is turn on LEDs, but only draws about 7 milliamps, not enough to turn a coil on.
Got a couple of questions, Dick.
Yes, sir.
Joe Hart says, what about a commercial relay tester that energizes? Will this hurt a relay with a diode?
Yes, if there isn't a way of determining, in other words, the polarity. If I'm just visualizing what Joe was talking about, if there was a tester that you hooked up individual wires to the terminals of the relay, and you'd have to know that terminal 85 is positive because that has a diode connected, reverse bias to it, then no, it wouldn't damage it. But if not, yes, it would, because the relay tester doesn't know which is polarity.
Yeah,
I would say yes.
And our own Russell C. Ferguson asks, why don't we just use an ohm meter?
An ohm meter can determine if there is a diode, and you know, I wouldn't use an ohm meter. I would use the DVOM's function test of diode test, which is a little more voltage than an ohm meter would be, and you're hooking it up one way and then the other, and you can see a change in your resistance if there's a diode. That will do it. I just don't do that anymore. I use a test light because I don't have to grab an ohm meter.
It's probably quicker.
It's quicker.
Yep. Okay, thank you.
You bet. And here is the test that very seldom gets done, in my opinion. This is called dynamic testing of a relay outside of the circuit. So we take a test light to energize the relay coil with and back to ground. So there's our coil circuit. Then we hook 30 to battery and 87, in this case, to a headlight bulb. Notice I use a seal beam. And the reason I want to use a seal beam or more than one seal beam is I want to test this relay in the same amperage family or the same amperage draw that the circuit it controls has. So if it's going to turn on a 20 amp circuit, I want 20 amps connected with either headlights or any number of resistor bridges or whatever. I want to have 20 amps going through that relay. In this case, I just have a headlight. That would be about a 4 amp draw. Now, what do I do with all that information? I measure the voltage drop across the contacts between 30 and 87. This measures the conductivity condition of those contacts. It'll determine if the contacts are pitted, corroded, or whatever. I want no more than 0.2 of a volt. The relay may click just fine, but it may be defective because the contacts are pitted because of too much current flow. Don't do this with a test light because there's not enough current flowing through the contacts to actually do a valid voltage drop test. There must be as much current flowing through the relay, or a little more even, than what the circuit was that it controls. Voltage drop across 30 and 87. Very important test.
Yeah, Dick, I have to agree because there's some of us that break those cubes open and put a piece of tape between the contacts, or I found clear nail polish works there. So
Yeah, the relay clicks, but nothing happens. And in this case, what would your voltmeter read if you did a voltage drop across 30 and 87? Who's got the answer?
Bill says 12 volts.
That's correct. That's a lot of voltage drop.
Bill and Jim, yeah.
Case scenario, case study. Blower motor was running slow. They did an open voltage test at the blower connector and it was 12.6 volts. So the blower was replaced, but still did not operate properly. What did they do wrong? Anybody know?
That ground, Paul says, I also discuss latching speed to my learners. I've come across relays, showed resistance. Bill says on the circuit, open circuit.
My question was, what did they do wrong? And the answer is they did an open circuit voltage test. They took the plug off of the blower motor, tested voltage, found that it was 12.6. They thought everything in that circuit is good except the blower motor because it's running slow. So they put a new blower motor in it, but it did not work. Open circuit voltage testing is a complete waste of time 99% of the time. However, they did a voltage drop test across the relay contacts and found that it was a 3.8 volt drop. That's why the blower motor was running slow. And I took the cover off the relay. It's hard for you to see that, but those contacts are really pitted. Now, why did they pit? Because the older blower motor was drawing more current than it should have because the commutator was partially shorted. So they thought they were fixing it with a new blower motor, but they didn't because they smoked the relay in the process of having that blower run for a long time. Always check voltage drops across your contacts. How many techs would have missed that diagnosis? If jumpering 30 to 87 or any others, please always use a fuse. Always use fuse jumper wires. It only takes a little second, at 186,000 miles a second, those electrons don't care. Make sure that you use fuse jumper wires. Or you could put a headlight in series with your jumper wires. The worst that'll happen is the headlight will come on. Okay, if we take a relay out, the relay is on the right, the circuit socket is on the left. You got to remember when you're testing relay sockets, what happens to 85 and 86? They reverse themselves. So 85 is over on the right and the left on the receptacle. 86 is on the right on the receptacle and the left on the relay. Don't let that get you in trouble. 30, 87A and 87 are the same. Dynamic testing. We have a fuse jumper wire connected between 30 and 87. And I've already checked my wiring diagram. I know that whatever this relay is supposed to energize should be running through that fuse. What can I do with that information? Make sure that you always check your proper wiring diagram before jumpering anything. Don't assume, never assume. Next, I put an ammeter in that wire or around that wire if it's an inductive ammeter, or with a fuse, I put my DVOM ammeter in series with the jumper wire. What will that ammeter tell me? Well, the answer is it tells me how much current is flowing in that circuit to the control device. Now let's say you have a fuel pump problem. The fuel pump just doesn't seem to be running at the right speed. You've done a scope current ramp of the pump. You've calculated your speeds and it's below what it should be. How do I determine what the problem is? Well, here's a trick. Do this test at the relay socket. Measure the current flow flowing in that circuit at this point. Now go to the end of the circuit, the fuel pump, the blower motor, whatever that relay controls. Connect direct 12 volts to the pump or to the blower motor and record the amperage back there or wherever the end of the circuit is. So let's say you got 18 amps at the device and you got 12 amps here at the receptacle. What does that tell you? There's a 6 amp difference between what you read at the socket and what you read when it was connected directly to battery voltage. What could explain that difference?
Waiting for the chat. Resistance.
There is resistance somewhere in that circuit. You know that for sure. If there isn't any difference between this reading and the one at the device, you know you don't have to start taking connectors apart, checking for green pins and corrosion. You've already tested the continuity and conductivity of the circuit with this simple test. It's like a current drop test. And I would say voltage drop, but it's a current drop test. You're determining the difference between current here at the relay and current at the device.
So
Paul says there's another current draw somewhere in parallel.
Possibly.
And Joe Hire says there's a bad connection somewhere.
That's correct. Yep.
And Bill Adams,
Okay.
why not just do a voltage drop test?
You could. I'm just giving you different strategies for different testing abilities for the relay and the relay circuit. Okay, now it's time to unmute all of your mics. If you don't know how to do that, Jimmy will do that. Go ahead and unmute. Be respectful of each other. There'll be somebody talking over one another. Just wait for your turn. What have I done here is created a pop quiz. I want you to look at the right-hand drawing. This is the schematic of this particular socket. We have 86 is connected to a fused source from ignition. 85 is ground of the coil and goes to a switch that is turned on and off. And of course, it would be a ground switched relay. 87 would go to the device, make it whatever you'd like. 87A is not used, and 30 is B plus power to the relay and the circuit. Now the relay has been taken out of the socket, and here's the socket that you see on the left with the terminals identified. Up at the top, you see a white, black, and red, white, plus and minus. So that's ground and positive of a battery or B plus source. Now I have a test light, and I'm going to connect it to socket 86. And I'm going to connect it to battery positive. Tell me what the test light will do.
Nothing.
Is this hot at all times or only when cranking?
What does it say on the schematic?
It says fused from ignition.
Okay. So if it's fused from ignition, it's going to be fused when cranking too.
Okay.
So what's the test light going to do? I've heard 2 nothings.
Nothing.
Steve
Nothing.
Cook says it won't light.
It'll be on, then it'll go off.
Why would it go on?
Initially, when you first turn it on.
Why?
No.
Relay's in route. It's out, right?
The relay is out. You're looking at the socket, not the relay.
Okay, sorry. Hold on.
That's okay. What if the light comes on when you
Sorry.
turn the key on?
That's correct.
It's backwards.
The only way that light will come on is if there's a short to ground somewhere in that circuit.
It'll be off with the key on.
That's correct. All right. How
Oh,
about
the
here?
switch is on, Dick.
Yes, switch is on. And we're positive to positive. The only way that light would come on is if there was a short to ground somewhere.
Oh,
What if the switch was on?
Nope.
Nope. Switch was on, you got a positive source here from ignition, and you got a positive source on your battery to your test light. That test light will not come on.
If 85 is switched to ground and the switch is on,
Remember, the relay is out of the circuit, Lon. The relay is out of the circuit.
It's positive to positive. You got same polarity or same
You have
potential.
the
in
same
both ends.
potential. You have the same potential. You have no current. Now I hook it to battery negative to 86.
hey, back
Yes.
up.
Sorry.
85 is switched to ground. If
Yes.
that switch is on, you're telling me there's no ground on 85? Unless
Remember,
He's not looking at
remember the
85.
relay is out of the circuit.
I'm
There
talking
is
about
no-
trailer. We're talking 86 to 85. That's just.
no, no,
I'm sorry. I thought the relay was in there. You're right.
no.
All
This is tripped up more than you, sir. Trust me.
All right.
All right, now we have the test light connected to battery ground or negative, and now it's on 86. What should the test light do?
Test light
on.
It should come on. What if it doesn't?
open some more.
Could be something as simple as a
Open.
blown
Yeah,
fuse.
open what?
Blown fuse. Remember, it's fused from ignition. So that's a great test to see if the relay coil has power. Good, let's move on. Now we're on 85. I've connected the test light to battery positive, and I'm on 85. What will the test light do?
Test light on.
Light,
Sorry?
It's on.
come on.
Maybe, maybe not.
If the switch to ground is closed.
There you go. This is the test to test the switching circuit of the relay. You connect a test light to 85 and operate the switch, whatever that switch is supposed to do. You make it do that, and you're testing the switching circuit side of the relay or the ground side of the coil.
But you didn't clock in.
What about now?
Off.
Anybody else say off?
Points with this guy.
Oh,
Stays off.
supposedly training for teachers and instructors.
Mhm.
Pointed out a couple of things as bullshit.
What is that?
He's telling me testing relay circuits. If
Yes.
I have different current in a different point of the circuit,
Yes.
what's wrong with it? What could potentially do that? If it's nothing. The current is going to be the same throughout a circuit, no matter what.
That is not
If I've
true.
got
Sir.
bad resistance anywhere in that circuit, it's still going to have the same current.
Maybe you missed my
Voltage drop
explanation
at different
of
points of it. I can pick up the resistance. or bad
maybe you missed my comment that when we test the device, I wanted you to connect it directly to 12 volts. Eliminate the circuit. Now you're testing the
And they
amperage of the
tell me
device.
that he was baffled with why he could use an ohm meter to test the windings with the diode. He said it won't light this way, won't light that way. No, with the diode test, it'll have a different current flow. But the diode's paralleled across the windings of the relay coil anyhow, so you're still going to have flow through it.
But it will not energize the
He's
relay.
missing out on the fact that it's a parallel instead of a series circuit with the diode. And wow. I say,
Yeah, these are not necessarily questions.
Okay.
Is this live right now?
yeah.
Yes, it is.
And Dick, we need to push out that quiz when you're ready.
Go ahead. We're not going to finish. We're not going to finish today. We got quite a bit more to go. So
Yeah, he's already past time. He's supposed to-
yes, I see that. Well, let's just finish this one. Let's
Well,
finish this one test.
it
What
will-
happens if I
again,
connect the test light to
down
positive?
another app to deal with this.
Device should operate.
Well, Yes, it will, but it may be dim depending on what the resistance of the device is.
Yeah,
'Cause
you
you
got some
connect,
voltage drop across the light. Some voltage drop across is lost across the light.
yes, you've connected the light in series with the control device. That is correct. All right, I'm going to stop right now because we're running out of time here, and stop sharing the screen and go back to where we were. Jeff is putting out a 10-question quiz that we've probably covered enough information to answer the questions. And we asked for your email, and we're going to use that to issue you certificates. The purpose of this presentation is not to tell you mine is the only way, the one and only way of testing relays and relay circuits. It is one way. If you've got a better way, by all means, use it. I'm just giving you some things that I have found that are missed by a lot of technicians regarding these procedures.
All right, I'm going to stop the recording just because we're over at this point.
Yeah, we are. I wasn't even looking at the time. I apologize.